Hi everyone, in last video we have gone through what is meant by transformer and what are step up, step down transformer and what are the windings involved in it, that is primary and secondary winding. And this video is completely on working of a transformer when it is at no load, and our next video will be on working of a transformer when it is at load. So let us come to know what is the behavior of a transformer when it is not loaded. See, firstly, already we have discussed this point in previous video. That is, a transformer is nothing but stepping up and stepping down of voltage and transfers of electrical energy from one level of voltage to the another level, right? And it works on the principle of EMI. I have put here it in a simple way. That is, it will take electrical energy as the input and it will transfer the same electrical energy as the output with the help of the principle of electromagnetic induction. Okay. Now, before knowing the working of a transformer, we wanted to know this two things. So firstly, if you can see, this is said to be your core, okay, and this or your primary winding, and this is meant for your secondary winding, and this is your source. So since your source is connected at this side, this is said to be source side, and since here it is load at, this is said to be load side. And when do we say that transformer is at no load? A transformer is said to be at no load when there is no load connection to the secondary side. See, this is your primary side and this is your secondary side. Whenever there is no load connected to the secondary side, then you define it as a transformer which is working at no load, okay. And the primary side or source side, it should be energized by an AC supply. That means at the primary side it should given to a AC supply, and at the secondary side it should be not loaded when the transformer is at no load condition, okay. It should be only in this way, okay. And what is the working? So in order to understand working principle of this, let us redraw the circuit in a very simple way. So here you can see, here you just have an AC supply, right? So draw this AC supply, and after that here you are having your primary windings. So make sure that you draw your primary windings, and let us suppose its voltage as VI, that is input voltage, and here we represent this core in the form of these two lines, since we are visualizing it as a 3D. So in 2D representation we represent in this way, and here is your secondary. So here is your secondary winding. And since we are discussing here about the transformer at no load condition, here it should be like should not be connected to any external agent, like any source should not be given, or else any load should not be connected, okay. And since your primary winding has more number of turns and the secondary winding has less number of turns, here you are using a step down transformer, okay. And now coming to this working principle, when primary winding is energized by an AC supply. See, firstly this is your primary winding, right? So how do this get energized? Means this primary winding is given to the AC supply, right? So since it is given to the AC supply, AC is nothing but your alternating current. So alternating current starts flowing throughout this primary winding, okay. This alternating current, see, firstly you have a transformer at no load, means your primary winding should be given to the AC supply and secondary winding with no load. And in this primary winding, due to this AC supply given, an alternating current starts flowing from primary winding. This alternating current will leads to the setup of the magnetic field inside this magnetic core, okay. See, inside this magnetic core, due to this alternating current, like this variation of this current, and what can we say, alternating magnetic field was created inside this magnetic core, and this alternating magnetic field will get interacted with the secondary winding, and it will induce an EMF in the secondary winding. As we have already discussed what is this what is the working principle. It works on the principle of electromagnetic induction, right? So see, firstly, uh, current is produced, and due to that a magnetic field was created, and an alternating magnetic field which was created will get interacted with the secondary winding, and as a result an EMF is induced in the winding. Okay, but since it is an open circuit, there no current will flow. We know that V is equal to IR and I is equal to V by R. In simple terms, current and resistance are in inversely proportional to each other. That means if it is open circuit, that is no current, then high impedance is nothing but like a resistance, right? High impedance in secondary circuit, because if the secondary circuit secondary winding, since the secondary winding has no current flowing through it. Okay, so this will get reflected on the first side. On first side it should not carry any amount of current, because the second side is open circuited, right? But it is not possible. Why it is not possible? Because without any source the energy cannot be produced, right? So on the primary side it should not carry any amount of current, as secondary side is open circuit, but it's not possible for the flux to set up without any energy. So here flux is created, and due to that this EMF is created, and hence it works, right? But without giving this supply, without giving current, it is not possible, right? So the main use of why we are giving this AC supply, that is current, is firstly to magnetize the magnetic core. Only when this magnetic core gets magnetized, then only the EMF gets induced in the secondary, and hence the transformer works, right? In other case it will not work, right? So we have to give current at the primary. Okay, that is at primary winding, the current which we give is said to be no load current. Okay, and the main reason for it is to magnetize magnetic core, and then to supply the core losses. So here you have this core, right? It is actually made of silicon steel. It is laminated with a silicon steel, and this core will create a it is made up of a low reluctance and high permeability material. Why it is made of low reluctance and high permeability material? In the sense, in order to efficiently change the magnetic flux. See, in order to change the magnetic flux between this primary and secondary windings with minimum opposition, it opposes the cause during which it is produced, right? In order to minimize those oppositions, and in order to efficiently change the magnetic flux between this primary winding and then the secondary winding, we use a core which is of low reluctance and high permeability material. Generally it is like silicon steel laminated, we can say. Okay, to supply the core losses, and this high permeability material is used because it will it will not waste any energy. Okay, so we use that. Since it has no finite permeability, that means high permeability, and offer a path for flux. This core is the only one, right, which is offering. So throughout this core there will be flux going through it. Okay, now coming to the graph, this was not much important, but just I wanted to discuss it. So here it will be your current at no load. Actually here you will have magnetic current. This IM refers to the magnetic current, and this IC represents to your core current, and here is your voltage, and this is I naught, which is your no load current. Okay, no load current. And here if you can see, this magnetic current lags this applied voltage by 90 degree, and this core current and this voltage were in phase. And if we take this resultant I naught, that is no load current, it will make some angle with this voltage, right? So that is about, this was not at all important, just I have placed it there. So this I naught lags V by a certain angle, let us suppose it to be phi, okay, or phi naught. And generally, since we have given here an AC supply, our graph between V and omega t is also like a sinusoidal one, right? And this was the diagram when the circuit was no load, not loaded. See here, I have by mistake I have placed that load here. It is not loaded. It was just open end like this. Okay, firstly here you are giving an AC supply, and here it is of an voltage V1, and here an E1 is induced, and due to the principle of this EMI, here E2 gets induced. Okay, and this was the path of flux that is inside the core. And low reluctance, this was already discussed. Low reluctance and high permeability material is used in a transformer core to efficiently change the magnetic flux between the primary winding and secondary winding with minimum opposition. This is what we have already discussed, and this is all about our transformer, working of a transformer and no load. Hope you have enjoyed the video, and if you have any doubts regarding this video, feel free to ask me in comment section, or else if you want me to make any improvements or any suggestions given from your side, I'll take it happily. And you're welcome. Thank you for watching, and our next video will be on transformer at load. Okay, bye bye. Thank you for watching.